Let's have an overview on sequences. What are sequences? Well, let me start from functions. We have been doing functions for quite some time, and I hope all the students have understood the concept. Most of the functions, the domain was set of real numbers, and we saw continuous lines. Sequences, however, are different in a way. They are still functions, right? In a way that there the domain is set of natural numbers. So we'll give a very simple definition to a sequence. So we'll say, what is a sequence? So we'll say a sequence is a function whose domain is set of natural numbers. So let's write that down. So what is a sequence? So we say sequence is a function whose domain is set of natural numbers. Set of natural numbers. So you remember what a set of natural numbers, right? That means natural numbers are denoted by letter n, and the numbers are like 1, 2, 3, like this. You see? So these functions, normally, we try to represent them also in general. Like we used to write f of x for functions. For sequences, we'll prefer to write f of n. And here, f of n will kind of remind us that this is a sequence when we're talking about. It's also a function, but in context of sequence, when we write, we prefer to write f of n. And let me write an equation function here, which is a sequence, as f of n equals to, let's say, 1 over n, because my input variable is n, right? So independent variable is n, and I'm writing n here, where n belongs to set of natural numbers. Correct? Now, this is kind of definition, and I've given one example here. So this is just an example here, right? So example, f of n equals to 1 over n, where n is set of natural numbers. And let's try to see how this is different from the functions which we have done so far. So if I have this f of n, let me just sketch it for you here. If I say in terms of function, I can write this as, let's say, function of f of x equals to 1 over x, where x belongs to real number, where I say x belongs to real numbers. So that function is a reciprocal function, right? You know this is a reciprocal function. And how does it look like? So you see the reciprocal function is kind of like this. The value decreases and it approaches to 0, right? It comes closer and closer and approaches to 0, right? Horizontal asymptote is this, correct? At 1, the value is 1, and let's say at 1, the value is 1. At 2, it becomes kind of half, and at 3, it becomes 1/3, and like this, right? So that is how the value changes, correct? Now, if I write this as a sequence, then I will write my sequences f of n equals to 1 over n, where n belongs to natural numbers. Now in that case, what happens is, let me make a bigger scale of this. Okay, let's say this is our 1, right? And this is 2. So here we have 1, 2, 3, and so on, correct? Now, since we can only have natural numbers as our input in a sequence, so, and starting with 1, so okay, 0 as such is not defined for that, the function which we are considering. So in this sequence, if n is 1, then we get a value 1 here. Do you see that? If n is 2, then it is half, so we get a value here. If n is 3, then we get a value 1/3, and it's kind of here, and so on. And as we say, it can move kind of like this, right? So we don't have continuous values when we are talking about sequences. These is continuous when x belongs to real numbers. But as soon as we limit our domain to set of natural numbers, right? Here x belongs to natural numbers. As we limit our domain to natural numbers, we find these dots here, the points, discrete points. Do you see that? So this becomes a discrete function. So we change from a continuous to a discrete function as soon as we change our domain from real to natural numbers. So sequences, when you are thinking about, think about natural numbers as part of their domain, and that will lead to a discontinuous or a discrete function. Correct? Now that is how it is. Now what we can do is we can elaborate more on this. Let us say this is our function f of n, and now we can write f of n equals to, if I put n as 1, I get 1 over 1, which is 1, right? If I put n as 2, I get 1 over 2, and then I got 1 over 3, 1 over 4, 1 over 5, and so on, right? If I put, in general, I could write this as 1 over n, right? And this could go on, correct? N could be any number where n approaches infinity, right? So this type of a series where we don't have a last number, the last number, we can call this as a sequence is infinite sequence. But if we kind of define n, that maximum value of n is, let's say, 100, then our sequence is finite. So in sequence, we'll also see the terms like, let me write down a few terms which we are going to see in sequence, which is, first is discrete, right? So it is not a continuous function, it is a discrete function. And second thing which we need, we just saw that this could be finite sequence, right? Or infinite, right? Then we also saw sequence will always belongs to set of natural numbers, right? That is the domain. Belongs to natural numbers. That is a domain, right? However, the range could be anything, right? Range could be real, right? Could be real. Is it okay? But domain always belongs to set of natural numbers. So these are important things which we have covered so far. Now here is our sequence f of n equals to 1 over n, where we have put some values for n, and so we get these different elements. So these elements are 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5. Each element in a sequence is called term. So these we call as terms. So we have elements of a sequence are called terms. And these terms are identified by their position. So terms have term number associated with it. For example, this is term number 1. So I can write this as t of 1, term number 1. And this is term number 2. We can write this as t of 2. And we can also write this as t of 3. In general, nth term is written as t of n. Correct? Term number. T specifies term. Sometimes we could also write these term numbers with letter A. So we said A1. A1 means first term and A2 will mean second term. So it depends. Different books use different nomenclature, and AN will mean nth term. So here Tn means nth term, right? Same is the case of An. It means nth term. Okay. Now, every term number has a value associated. For example, what is the value of second term? The value of second term in this sequence is 1 over 2. The value of fifth term is 1 over 5. And the value of nth term is 1 over n. So those are the values of a term, right? So every term has got a term value, or value of term. So we'll write term value here, Now, this is kind of important. At times, when we are given a sequence, we need to find out what is the general term. When we say general term, that means we are talking about the nth term, this term, right? So this term is also called general term. A function may define the general term. For example, can you write a general term for this function? Yes. Here you see the numerator is always 1. So we write this as 1. 1. And the denominator changes. And denominator is same as the term number. Term number is 1, denominator is 1. Term number is 2, denominator is 2. So it is same as term number. So n is the number of terms. Therefore the function is 1 over n. Do you see that? So that is how you can get relation between the terms and their values. Now here is a small question for you. Can you write general term for this sequence? If I write 1 over 2, 2 over 3, 3 over 4, 4 over 5 and so on. Can you write a general term Tn? How will that look like? Now as you see, term number 1, term number 2, term number 3, these are the term numbers. And let us see how these term numbers are related with the value of term. We say numerator is same as the term number, right? If it is 3, it is 3. If it is 2, it is 2. If it is 4, 4. So here I can write n in the numerator. So n will mean, for n, it should be n, right? How about the denominator? Denominator is 1 more than the term number, right? So 2, 3, 3, 4. So I could write denominator as n plus 1. So that becomes the nth term for us, correct? So if I know the nth term, I can define my function. So in this case, I can define my function as f of n equals to n over n plus 1. Okay, so I got a sequence, correct? And I could define my sequence with the help of my general term. And how do I get the general term? We get general term after relating term number with its value, correct? So that's how you get general term. At times, general term is given to us and we need to find the sequence. For that, plug in different input values of n as natural numbers from 1 onwards or given in the domain and generate the outputs. And all those outputs will form a part of your range. Remember, domain is always set of natural numbers, but the range could be real numbers or any other set of numbers. Okay, I hope you understand the whole concept and get an overview of sequences. And now we will do more problems based on sequences. Thank you.